John here. Welcome to part 4 of my 3D printable 7-segment LED design video series. We just finished trying to get this separator and retainer in here for the LED strips. Let's move on to now actually creating a 7-segment LED. We got the 1 segment. Let's put 7 of them together. So to do that, what we really need to do is simply piece these all together. They're all the same at this point. And we will, so we make many copies. So let's make a back 7 module. All right, what we need to do, I don't know if you can hear that. There's quite a thunderstorm going on outside right now. What better thing to do than to sit in the basement and work on code during the thunderstorm? Hopefully we won't lose power. Okay, so what are we going to do? We're going to, the middle one is going to be the easiest, right? There'll be one across the middle, a top one, and a bottom one, and then 4 of them around the side. So let's go ahead and do the middle one. And then we're going to make a, whoa, mouse going nuts there. Make a back piece. And instead of saying back, we'll say back 7 here. Well, here's the first one, right? Now to do the top one and the bottom one. Well, the only difference between the top and the bottom is where they are. So they're not going to move in X. They'll move in Y. The top one will move up somewhere. And then not going to move in Z either. So basically, it'll look like this. It needs to move up how much? Well, we know that the outside length is this edge here. So this corner here needs to move up that much. So the center has to move up this much plus 1 outside length plus half of this width again, and that width is the outside width. So that's pretty straightforward. Let me go find the variables. Where's my outside length? There we go. So he's going to go up this much plus the outside width. 2 halves of the outside width plus 1 outside length. I'm going to put parentheses around this so that they're both basically the same, except the bottom one will have a negative in front of it. So that's up and down that much. And do a save, and it replots it. And that's about where they should be as well. This is the 100, there's the 200. So we know that this outside length for 5 LEDs is just less than 100. And then we got half a width and a half a width, so that's about 100. So this looks like what we would expect for those 3 segments. Now the left ones and the right ones are not going to be rotated. They're going to be the way they were originally. They're not going to move in Z, so they're going to move somewhere in X and somewhere in Y. What are they going to do in X? Well, we know that the center of the segment, if we don't move it at all, is right on this origin. We need to move the center over to the tip of this, which is half of the outside length plus this distance in here is half of the outside width. So that's in X. So we're going to be minus 1 thing there. And then in a Y, I got to move the center of the segment from here to there. Which is what? That's half of, it's the same amount. It's going to be half of the outside width plus half of the outside length. So both of the X and the Y will roughly have the same value, and they're going to be based on these variables. So let's go ahead and paste that in there. What am I going to do? I'm going to go over outside length over 2 plus this guy. And then in Y, he's going to go really quite the same thing. And he's either going to go up or down. So that should be the top one. There you go. The bottom one should be the same thing, but move it down in Y instead of up in Y. So we just put a negative right there. Bing bong. We're looking pretty good so far. Now we need to do the right side. Well, that's really all the same sizes as well, but changing some signs. Instead of going negative X and so on, it's the same as this, but this negative goes away. And the bottom one on the right is the exact same one as the bottom one on the left, except we go to a positive X. And there you have your 7-segment LED. But as we'll see in a second, it's not really done yet. I just did a full render to double check. See how I got 8 volumes here? That's 1 volume for the outside and plus 1 for the inside of each one of these 7 segments. So what that tells me is these 7 segments are really not joined together. They are not touching. Now, if I were to render this and print it, it would probably be fine because they're separated by just a small teeny weeny amount. In fact, we could zoom all the way in and you can't even see the gap in there. It's so small. It's caused by rounding off of floating point numbers inside the algorithm. It should be 0, but there's usually a little bit of noise and fuzz in floating point calculations. So to make sure that these all join, what I'm going to do is the X, when I move to the negative X for these 2 segments, I'm going to move it just to the right ever so slightly. So if I'm going to go minus in that direction, I'm going to say plus 0.0001. Plus point. Oop. And of course it doesn't move that much visibly, but I'll bet anything we just lost some of our volumes. Now we're down to 4. Same thing here. I'm going to move it right in the X, and then we're going to minus 0.0001. This is no real difference, but when you zoom way in on the micro scale, this will make a difference, and it'll turn the entire system into one single volume, which is optimal for 3D printing. Some tools won't be able to deal well if there's these little tiny gaps in there. So you see this crop up from time to time, and that's why. It's because it's ever so slightly off, just a smidge. This is fine. It won't really change anything. It'll all, for all intents and purposes, your 3D printer will round off in its head movement by far more than this. So this is perfectly fine. All right, so I got a 7-segment for the back. We need a 7-segment for the front as well. Turns out the front and back are really identical. But we're going to see some other differences between the 2 as we move on. So I'll make this a front 7. And instead of creating backs here, we'll create fronts. You'll see that these will diverge. So this, I'm just looking ahead a little bit on what might be in the next part of the video series here. Make this into front 7 and call that instead of back 7. Oops, I missed one. There's a back in your front. The middle one. Oh, that's this guy right here. There we go. So there's the front. Again, let's do a full render. Make sure that we have 2 volumes. That's the volume of the inside of the area and the outside. So there's the front piece and the back piece. Now, when I make mine, I like to slant them, so it looks, a little bit cooler, I think, anyway. Now, to that end, what I did is I went out on the net, Googled around, and I found some code that somebody wrote. It turns out it's in a comment on someone else's code where somebody simply posted a solution. So what I did here is I included a note that says, by the way, this came from this GitHub page, but it's not the GitHub code that this guy wrote, this guy here. It's somebody named Ziggy90127, perhaps from a suburb of LA, given that zip code, I don't know. This is one way to skew things. This is kind of documented in the, well, it is documented in the OpenSCAD doc, but this specific example seemed pretty cut and dry on this link. So feel free to go grab a copy, or I'll put a copy of this in my, along with my files as well. So what we're going to do is include this in this program, and the way you do that is you just simply say pound include I put it in the same directory as the file I'm editing now. What do you just say, include? I'm too used to writing C code. So we need to include that file in this file, and you saw it at a function called skew. So if I simply say skew, and the way it works is you have a vector of angles. So let's say I want to skew it, I want it at 9 degrees to the right. There you go. Now you got your LEDs looking like this. Now you got to be kind of careful. Remember, the front is rendered upside down. You're looking at the back of the front right here. So if you want to skew the front, you need to go the other way. And the back, you're looking at the front of the back and the back of the front. Yeah, that's obvious. So let's comment this one out. If you're going to print these, you need to do it like this. The back, this is the right way. You want your digits slanted. Then when you render the front, since I'm rendering the front upside down, you need to skew it the opposite way. But you need to make sure you use the same angle or they will not fit together. So this is how I made my 7 segments. Actually, 9 looks too slanty. I'm going to go to 6 here for this. That looks a little bit closer to what mine I used on my test prints earlier on. So there's how you create 7 segments out of 1 segment.